In this lesson, we're going to look at how to find molecular formulas. It's very similar to empirical formulas. To find a molecular formula, you have to have two pieces of information. You have to know what the empirical formula is, and then you have to know what the real-world mass is of your compound. Now, we talked about in empirical formulas how sometimes the empirical formula is the real-world formula, but oftentimes it is not. The molecular formula is that real-world formula. What we have to do is check the weight of our empirical formula, compare it to the real-world mass, and see if our empirical formula is off by some factor. We're going to take this worksheet and we're actually going to start at the bottom. Okay, in number 4, we're being told that our empirical formula is CH. The mass of that formula would be 12 for the carbon plus 1 for the hydrogen, which is 13. Now in the problem, we're told the molecular weight, which has to be determined in the lab, is 78. Well, obviously, 13 does not equal 78. So there's a difference between our empirical formula and the real-world molecular formula. We want to divide those two, always molecular over empirical, to see by what factor our empirical formula weight is off. So here we get very close to 6. So now we're going to take that 6 and we're going to multiply it by our empirical formula, and we're going to get C6H6 as the molecular formula for benzene. The empirical formula is simplest whole number ratio, that's why it's only CH, but the real world formula for benzene is C6H6. Alright, now in number 3 we have butane. So let's add up the mass of C2H5, our empirical formula as it's given. So that's 2 times 12 plus 5 times 1, and that equals 29. Okay, we're told that the molar mass, molecular weight of this compound is 60. Obviously those aren't the same numbers, so we're going to divide again. 60 over 29. And it doesn't come out to be exactly a whole number. Remember, we aren't doing a very good job of rounding here a lot of the times, but that is very close to 2. So let's multiply 2 by the empirical formula, and we're going to get C4H10, which is the real world formula for butane. Let's do one more pretty simple one. This time we have vitamin C. The empirical formula is given. C3H4O3. Let's add all of that up. 3 times 12 plus 4 times 1 plus 3 times 16. And you get 88. Again, that does not equal what the molecular mass is found to be in the lab. So let's divide. Again, it doesn't come out to be exactly a whole number, but it's pretty close. It's almost 2. So the real world molecular formula for this compound is C6H8O2. And finally, in number 1, we're not given the empirical formula, so we have to go through all that work to figure out the empirical formula. We are given the molar weight of the empirical formula, so we need to find the empirical formula and check the mass. So let's begin with our 100 grams, and that allows me to have 75.46 grams of carbon, 4.43 grams of hydrogen, and 20.10 grams of oxygen. Okay, we'll save a little space here, so bear with me. I'm converting all of these to moles, so I'm dividing by the molar mass. So 12 for carbon, 1 for hydrogen, 16 for oxygen. Those moles come out to be 6.28, 4.43, and 1.256. Okay, So now we have our mole ratio. It is not simplified, so we're going to divide by the smallest, 1.256. We'll get 1. And the middle one's a little trickier than what we saw in class for rounding. It's like 3.51 something. We're going to round it to 3.5. And then this one's almost exactly 5. So we're going to have to multiply everything by 2 in order to get the whole numbers. So we're going to have 2, we're going to have 7, and we're going to have 5. The empirical formula is C5, H7, and O2. And if we add up all the weights of the elements there, we get the molar mass to be 159, which does not equal the 318. So let's divide that. 318 divided by 159, and that's going to be right at 2. So our molecular formula will be C10, H14, and then O4. All right, that's molecular formula. It's pretty simple once you know how to figure out the empirical formula. But remember, we have to get that molar mass in the lab, and then we're just checking our empirical formula to that lab information to see what the real world formula would be. Let me know if you have any questions.